These are the electronics that I'm going to be installing in my new electronics cabinet. I'm going to briefly go through, then connect them all up on my saloon table and try some integration tests before I install them in place. So the first thing we're going to look at is this, which is a Samsung second-hand tablet. It's an A series, nothing amazing, but very cheap. And that's going to be used as a portable display for showing the any of the electric boat data, navigation, autopilot. I'm going to look for a second one, and I need some advice on this. The one that's a waterproof, robust one. This one is not waterproof, so I can't use it outside the cabin. And next to that is an old Samsung S20 22 phone, which is very good at running Navionics and DeX, and I'll be demonstrating those in a moment. To connect those two up to different things, I've got a couple of USB hubs. So this one has a number of connectors and plugs into USB-C. This one has a number of USB 3s that connects to USB-A. I've got this device, which is it basically will plug into a tablet, an Android tablet or computer, and then it'll convert it into a HDMI screen. So what it does, it emulates a webcam, and what it does is it takes the input from HDMI and inputs it through USB as a webcam onto screen. So I can use a webcam viewer and view, say, my Raspberry Pi on my Android tablet. It's much faster than VCN and other things where it's streaming over data. This is a HDMI to USB connector, so it's very fast, low latency, and that will work with either the Android tablet or the Samsung phone. So I can use them both as a monitor Raspberry Pi if needed. I've got a couple of small USB cables. These connect USB-C to USB-C. They're 40 gigabits. I bought them from China, so they're probably not, but they seem to work very well, and they're quite small and short, easy for interconnecting these devices in the cabinet. I've got a USB power measuring device, which will enable me to measure the amps and voltages used by my different USB devices. That will give me some idea of sort of power consumption, and I'm going to be using that as part of the testing. Next, I've got a large flat screen monitor. This is a imported phone. It cost me about £40. So someone has taken a laptop screen, a 16-inch laptop screen, and put it in a metal case and put the interface board on it. So it's got 2 USB-Cs, a HDMI and USB out, and it's got on-screen touchscreen, and it basically allows a very thin, low power monitor to run off 12 volts through USB-C. To control that will be plugged into both the DeX phone and the Raspberry Pis as their main interface. To control that, I've got this, which is an air mouse, and I don't think this is going to work at sea because it's basically using an accelerometer and a digital compass to detect movements of your hand to control a mouse on a screen. And I think if there's any sort of serious motion in the sea, this is going to get confused, because if I'm holding it still, it's still going to be moving because the motor's going to be moving. So I'm going to test that. I think I've got to get a better solution for that. I've got a little dongle for that, which will plug into one of the hubs, and that both acts as a mouse and on the back as a keyboard. So I might be able to use it as a little portable keyboard, even if it doesn't work as a mouse. I've got this, which is a open source watch, and I'm going to be transmitting key boat data to this watch using Bluetooth low energy broadcasting. So this will be able to pick up. At the moment, I've written this small test watch face for it, which has some icons, and it just steps through them, and it's very simple. I'm going to add some extra icons to this, so if you hold down, you can then change what's in each step. You can go to, say, I want wind, I want waves, I want sea temperature, I want depth, and then this will give you basically key boat data on my watch, so wherever I am, I can have a quick check of key boat data. So Next, I have some Raspberry Pi pieces. So I've got a number of micro SD cards, some micro SD card reader, some flash drive, USB flash drives, and then 2 Raspberry Pis. I'm going to have 2 Raspberry Pis always because I'm buying some waterproof mounting boxes to securely mount these so they don't get any salt or any moisture on them. I'm going to seal the cable exits to the boxes, and those will go inside the cabinet. So they'll be inside the cabinet and then mounted inside a waterproof box with waterproof grommets. I'm going to run these off small DC to DC converters. So this gives takes in 12 volts, it gives out 5 volts at 3 amps. I've got a number of those, and basically they're from China, so I don't really trust them. So I'll be using the USB power thing to actually find out, can they actually deliver what they say on the label. But they were just $1 or $2 each, so probably not the best things to buy. Next, I've got I'm going to have an SDR, so that comes in a few pieces. So this is an RTL SDR, and it basically has a radio connection on one end. You can connect any sort of radio signals from this, from like UHF gigahertz down to kilohertz, and then it converts it to USB, and it transforms the a section of the spectrum from analog to digital, so you can listen to multiple radio stations at the same time. You can watch television, you can scan your VHF bands, you could listen to ham radio, you can listen to shortwave broadcasts. It's a very flexible device that basically it's a digital radio receiver. This doesn't transmit. So I'm going to use that. I'm going to use a couple of those linked to the Raspberry Pis to both do my AIS integration. So I'll have an AIS receive. I'm looking at an AIS transmitter. I've got some interesting things which I'm going to show in a few weeks. But this will provide my AIS input. It will also provide digital radio and digital television. So this linked to the Raspberry Pi, linked to the 16-inch monitor, will be a very good TV set. So if I'm out in some island somewhere and I want to watch local news, I can pick it up. It'll pick up digital TV, analog TV, and convert it through a little application into playing on the screen. That's that. And that links to this, which is a ballon. And this is a very small little impedance matching transformer. So this allows me to, when I'm out at sea, out of range of anywhere, to pick up high frequency just using a simple line antenna. So it basically takes the input in through the aerial connector, and it has a tiny little match transformer. And actually it goes the other way. Input comes in here, wires, aerial and earth, and then it goes through this tiny little, let me see if I can get this in focus. There we go. This tiny little transformer, and transforms it to the right impedance for my SDR, so I can pick up HF with a very low cost antenna. I've got a number of power supplies. So here's one that is a 3 amp 5 volts. This one is a half amp 5 volts from 12 volts, and I'll be using the correct power supply. So these ones for Raspberry Pis, these ones for smaller devices, and these ones for my ESP32 devices. If I slide over a little bit more, I've got some M5 stack pieces which I've been having a lot of fun with. So this is a screen which has a touch screen, a rotary encoder, a button, there it is, and it has some data buses. It takes in from 8 to 24 volts. I can run it off my batteries, and it can plug in, say, these smart lighting panels or sensors or anything I want. And I can have one of these in each cabin, connected over Bluetooth Low Energy and Wi-Fi. So I'll be able to turn the lights on up and down, go to red light, white light, and look at key boat data. And they've also got an NFC reader. I've got some NFC cards, so you can touch a card on there. So if you've got your watch and you're sitting in the saloon, you can just touch this and it'll count down your watch. If you're in the cabin, you touch this with your NFC card, it will wake you up and tell you your watch is going to start in 5 minutes. So it'll be sort of watch management as well, and just hand out low cost, like 30 cents NFC cards, which this can also program. Next I've got this, which is an AC measuring device, and this will measure current, wattage, voltage, frequency, power factor, and I'm going to put that in strategically behind some of the 240 volt sockets in the, so I can measure sort of where my power is being used and display it on the Raspberry Pis. I'm going to do this, which is going to be digital switching for some of my key pieces. So this is a relay block linked to a very low cost ESP32 module with Wi-Fi and Bluetooth Low Energy and a few buttons, and that will and it's got a serial connector to switch them and LEDs to, and that will allow me to digitally switch key components of the boat. And then last of all, I've got this, which is an unopened packet from China, and this is a set of components and boards which I'm going to go for another video. It uses a Teensy 4.1, which is a fairly high performance single board programmable computer, and a number of RF components, and this is going to hack these. So I've got a completely wireless system, a very old wireless system on my boat. So my depth sensors, my wind sensors, my speed through water sensors, all connected wirelessly using Tactic, and this runs off solar cells, and it's a proprietary wireless system. Someone has hacked it, and this is a kit of parts that I've found on AliExpress to actually install that hack, and it will then output all of that data through Wi-Fi and also take other boat data and display it on my wireless instruments, and it'll link it to NEMA 2000 and CTOR NG and older boat networks. And I'm going to go through that. Not going to go through this much, but I'm not even going to open it on this video, but it's something coming up, and it equivalent, you know, this is really a closed proprietary system. This allows me to use it all without replacing all my existing instrumentation. Okay. So next I'm going to plug all this together, and we're going to do some integration testing, see how this equipment talks and see what some of it can do. So in a few seconds you'll see it all connected and powered up. Okay, so I've been plugging things in and testing, and I've got this working after about 20 minutes of messing with software versions. So what we have here is a anchor power brick powering a Raspberry Pi 3 linked to USB and SDR RTL SDR, which has a simple antenna in it that is going to be picking up live AIS broadcasts from my vicinity. I'm in Clyde in Scotland in Europe, and there's not a lot of boat movement today because the weather is terrible, really misty, really rainy. So most boats are in harbour, but they're all broadcasting. Well, a few of them are broadcasting AIS, so you can see them. So this is also connected to a USB puck, which is picking up GPS live from satellite. So that's that little box there, that plugs into USB and also plugs into a USB keyboard mouse dongle, which is linked to this, which is my keyboard air mouse to control it. And then this is plugged into, let's this around a bit, my flat screen monitor, which is from a laptop, and that plugs into through HDMI, and then I can switch that through the switch in the input, and I can control the air mouse on here. And you can see here we have 1, 2, you can see me in the center in red. I'm bobbing about a little because of the wind, so it is picking up that I'm turning. I'm fairly stationary, but it's the inertial pieces from the Raspberry Pi sensor hat. It's measuring my rotation. It thinks I'm moving a little bit, but I'm not really moving that much. And here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 boats being picked up by RS, all the tankers. So there's a ferry there in dry dock. There's another ferry there being worked on. There's a boat that's on the hard up on the side there that's still broadcasting AIS. There's one in the same, just on the other pontoon there. And then there's a few working tugs from the local industry there moored in the tug harbour, which is the next harbour over from me, and the red one is B. So picking up AIS, so this is all done very low cost, and it's to pick it. So the AIS is through an AIS decoder, picking up channel A and channel B VHF. It's decoding the extra signals through the antenna, through the RTL. It's then sending it to Signal K, which is a very modern piece of software, open source, that is basically a signal multiplexer for boat data. So that can then bring in all different boat data, all different formats, and transmit it out in all different formats. And it has a number of plugins. So that is then sending it through TCP over. The AIS data is sent through from Signal K through TCP, and that travels both locally to Opencpn and over the Wi-Fi to my tablet and my Android DeX-based phone. And it also, I'm going to have a USB to Anima, old and new version, to send it to the existing navigation equipment on the boat. So you'll be able to pick it up on the old chart plotter. So, and I ordered a AIS transmitter, which is an open source one, which I'm going to be installing in the next month when it arrives, which will allow me to both receive through SDR and transmit AIS, so other people will see me and I will see everyone. My second-hand Samsung phone, I have got a USB-C cable plugging into this monitor, and I've switched the monitor over to DeX mode. So this is a full desktop environment for Android, which is provided by every S series Android Samsung phone, and this allows me to run applications in a sort of computer way rather than a mobile way. So here, if I want to run Opencpn, double click on it, and I have got Opencpn up and running, and this allows me up to navigate around and see where a full Opencpn implementation is much faster and smoother than running it on a Raspberry Pi, especially the Raspberry Pi 3. I've got to upgrade to a Raspberry Pi 5, and it gives me full features of all the plugins, and but it's Opencpn running on Android, and this will also pick up AIS targets from the Raspberry Pi. So I can switch between the screens just by in here. If you see here, it says, and I can switch that back to the Raspberry Pi, and I can switch it back to the DeX screen. DeX is good for web browsing, sort of media like Netflix, 4K content. It's just a bit slicker than Raspberry Pi. I will be using the Raspberry Pi for all the server data. This will just be used for the display data. Here's a quick example of the DeX desktop mode, as I'm going to be using it on my boat. So here we have Opencpn running in a window on the desktop. We have Windy running in another window, and then I have YouTube with my my channel running in YouTube. It's ideal for watching videos because the S20 is a good video player, so I can watch 2K, 4K videos nice and smoothly. This is me on my hike last year in Portugal. Here is my Samsung Tab A running Navionics. So you see here, it's picking up the AIS from the Raspberry Pi through the local Wi-Fi, and it's very slick to run Navionics. And here I can see a ferry tugboat actually, and this gives me all the AIS alerts, like if I'm approaching too close or if something's heading towards me or something's coming in certain range, all within Navionics rather than Opencpn. So if you have any questions on this, I'm going to go into much more detail. So the next stage is to install what I've shown you today, which is stage 1, which is the Raspberry Pi, the SDR, the flat screen, the Samsung DeX phone, and all the cabling and all the little power supplies to power it. So I'll be installing that over the next day or two, and I will be sending a video up on that. So so check back soon, and all this will be integrated into my boat.